All right, so we're going to look at this question, which this is the question right above the T analysis or the T critical value analysis. So in this case, when you read this question, this is all about doing what we call a Z interval. The reason why I know it's a Z interval right off the bat is, first of all, I have lowercase sigma, which is 116. So if you notice the simple random sample of 100 students, the mean of their test score is 458. Assume the population standard deviation. That right there, that sentence is what's telling me, given that that's population standard deviation is lowercase sigma at 116. So the four elements that you're going to need, since this is a Z int, it's fairly easy to do. You're going to follow the same protocol as we did so in the prior, except this time you don't need a degree of freedom. So I'm going to put lowercase sigma, okay, and then that we have sample size. They're giving us a sample size, so sample size, that's 100, and then our confidence level of 99%, which we know we have to take that 1%, split that 1% in half. So in other words, we're going to say equals 1 minus the 99% in decimal form, so 0.99. And see how that gives us 0.01? So now we have to take that 0.01, we have to split it in half, which gives us 0.005. Our final answer here is equal to 0.99 plus the 0.005, 0.995. So that's what we need here. And so I'm going to go with equals NORMS. We need inverse because this should be 0.995. And that's the Z-score we need, okay? So just listen to it again. Maybe you didn't capture everything I said initially. So we know that their mean score based on the question is 458. That's given to us. The lowercase sigma indicating the 116, which is our population standard deviation, a sample size of 100. Okay, and so we're going to do the confidence interval. So we're going to do the lower confidence level. That's one interval. And then on this side, we'll do the upper confidence level. And so our numbers should match that confidence level that's given to us there. So this is going to be equal to the mean. We're going to go minus parentheses our critical value, Z critical, times our standard deviation of 116 divided by the square root of 100, which we know is 10, so I'm just going to put 10 there. You notice that's exactly what I got. What I'm going to do is I'm going to control copy that cell and I'm going to drop it over here, control V, except I'm now going to say escape, and I'm going to now change that negative to a plus. That did not work. Let's not do that. All right, so let's go with equals the mean, in this case plus parentheses that critical value times, you could do parentheses to preserve it, which you might want to actually do that. I meant parentheses, not 9. Okay, yeah. That's incorrect, so hang tight because I'm still fixing this. So times, and I said instead let's do parentheses here. Again, 116 divided by 10 because that's a square root of 100. So See how we get 4788? The only thing you are going to have to do to get the answer to 3 decimals is go up to the home tab and look for this little guy here, and you'll see you get the same confidence interval as here. So in terms of interpretation, we would say in this case we are 99% confident that we would find the mean score to be between 428.12 and 487.88 among the freshman class entering. Okay, and so that's a simple interpretation. On this one, we don't really need much calculation. It's more discussion. If the sample size were 75 rather than 100, okay, would the margin of error be greater or smaller than the result? Okay, so basically, we're going to repeat that process. So this is the confidence interval with n equal to 100. Okay, now we're going to change that sample size to n is equal to 75. We've had this discussion, but I'm fairly sure that you've forgotten. So this is equal to, the upper is equal to the 458 plus parentheses. We would do the same critical value. This is times. This would be 116 divided by the square root. See how it comes up? Of 75. If this is difficult for you, and it could be a little taxing, what I would suggest is perhaps try it with a different cell. So in other words, do square root of 75 separately. It's square root of 100 was easy because we know that that's 10, right? And then we repeat the process over here. This is equal to the average minus parentheses our critical value, again, times parentheses 116 divided by, again, SQRT, double click on that, put 75 and close that, and I get 423. So if you notice, the interval looks like it widened. So you would have a larger margin of error because the sample size gets smaller. You get a larger margin of error. So I'll write it down so you don't forget. So the larger the sample size, the smaller, and we discussed this in one of our class sessions online with Zoom. So the larger the sample size, the smaller the confidence interval, which means a smaller margin of error, and the smaller the sample size, the larger the confidence interval with, sorry about that, which in this case means a larger margin of error. Okay, and then in this last part, what they're asking you to change, it says if the confidence level were 95% instead of 99%, given all else the same. So in part C, we're looking at, again, the mean, no change, that's going to be 458. The lowercase standard deviation, lowercase sigma, that's what I really want to say, sigma. That doesn't change, that's still 116. Our sample size at 75, that does not change. And our confidence level, 95%. So we're going to use a critical value of 0.975. Okay, and that will not change either. Okay, so I'm actually going to put it up here, 0.975. 0.75. And notice I'm using the decimal equivalent. So again, UCL compared to LCL. Let me go back. I meant LCL because it always comes first numerically, then UCL. Upper confidence level, lower confidence level. And so this is equal to, wait, before I do that, I forgot to do equals norm S dist, actually norm S inverse of that value. I have no idea what just happened, so let's try this again. I'm trying to get this down here. So equals norm S inverse of 0.975. You get approximately 1.96. So the lower confidence level is the mean minus parentheses the critical value times another parentheses, because just to keep it clean, the 116 divided by the square root. So you double click it, and now we want to do the 75. Hit enter. Actually, parentheses, whatever. There you go. And on this side, we want to do the same thing except plus. So equals that mean plus parentheses the critical value times another parentheses the 116 divided by the square root of 75. But here's the beautiful thing. You know how I messed it up and I put 75? If I go 100, they'll both change. See? So the question now becomes, if I compare the 95% confidence, which I'm going to highlight in yellow, with the confidence that we initially obtained with 99%, I'll highlight that in, let's go with the light orange. When you look at these two values, the question is what's happening. So I'm looking at 435 to 480. It looks like it shrunk. So it got, it didn't widen. It became more narrow, right? And so when we look at our explanation, it says no, because the confidence levels are less than 500. Okay, would the margin of error be larger or smaller as a result? I would say it becomes slightly more narrow. So I like how they say larger or smaller, and then they say no. Okay. So it does become more narrow, basically. All right, and you can tell by just numerically what's happening in there. All right, so let me leave you with this question.